In this video, we're going to review how to use elimination to solve systems of linear equations and go into some more detail, try some more challenging examples. So here we have two equations and we are going to solve them, meaning we're going to figure out what solution will be true for both equations at the same time. If we were to graph it, we would be figuring out where these two equations would intersect on the graph. So I want to review some concepts first, which is a reminder: 3x plus 2y is equivalent to 10. So these are interchangeable. And negative 3x plus 4y is equivalent to 2, meaning those are interchangeable. So if I were to say something like 3x plus 2y, that is this right here, and let's say I were going to subtract negative 3x plus 4y, subtracting this right here. I'll underline it here with this matching color. That would be equivalent to saying 3x plus 2y minus 2. These two things would be equivalent because these are interchangeable. Also, I want to remind you that whatever we do to one part of the equation, we do the same thing to the other. To keep them balanced, it will not change the end solution. So what I mean by that is you have seen examples of balances or hangers in the past, and we like to represent equations with images sometimes to help our mind wrap around what's going on. So if I look at this equation here, 3x plus 2y equals 10, and I'm going to represent each x with a blue circle. So there are 3 x's. And then I'm going to represent each of these y's with a yellow triangle. So there are 2 y's. And what I'm saying is that you need all of these to balance out this 10 because these things are equivalent. Now, if I were to take this here and double it, so I have these 3 blue circles, these 3 x's, and then I'm doubling my 2 yellow triangles, my 2 y's. Then I also have to double what those 3 x's and 2 y's are equivalent to. We would represent this mathematically like this. So 3x plus 2y equals 10. And I said I am doubling it. So I'm multiplying it by 2 here, and I'm multiplying it by 2 here. Just remember to put the parentheses around this expression, so you know that when we do multiply, this 2 gets distributed to each term in that expression. This concept becomes very important when we practice elimination, because remember, in elimination, we are looking to eliminate particular variables, so we're looking for matching coefficients. So I'm actually going to go ahead and turn the page so I can show you how we can use elimination to solve this here. And that way we have plenty of room, because you know sometimes get a little messy and write all over the page, which might be an okay habit once you're really comfortable with this and familiar with this, but not particularly helpful if I'm trying to explain to you what you're doing. So 3x plus 2y equals 10, and also I want you to get into good habits of writing things out as neatly as possible. So this was our system of equations. Now there are actually two different ways you can use elimination to solve this. And in order to show you both ways, I am going to use elimination to solve for the x and elimination to solve for the y to give us our complete solution instead of using any sort of substitution. So in previous examples, we had looked for an exact same coefficient, meaning the number and the sign were the same, and then we could have used subtraction. Here, you will notice this 3x and negative 3x. The number is the same, but the sign is not the same. Everything else is lined up, our y values, our numerical values. So what you should think about is, what do I need to do to this 3x and negative 3x in order to eliminate them? And what should come to your mind is addition, because 3 plus negative 3 is 0, and that's what we want to end up with. We want to end up with 0 x's. So I am going to add the parts of this equation to this first equation. So I already know 3x plus negative 3x is 0. 2y plus 4y is 6y, and 10 plus 2 is 12. Just out of habit, I like to rewrite it again without the 0, and remember, sometimes drawing a line with the equations keeps things balanced. As you're practicing, as you're learning, it's a good habit to write every step down. That way when you go back, you can check for mistakes. And I still make mistakes. I still have to go back and figure out, oh, did I leave a negative sign out? Did I write my number down wrong? In fact, this is the second time I'm doing this page because I wrote 2 for half of the problem, and then I randomly wrote 12 for the second half of the problem and got a completely wrong answer. And because I wrote everything down, I could go back and see what I did wrong. All right, so back on track here, we're isolating this y, so that means I'm dividing that by 6, because 6 over 6 will give me 1, and I'll have 1y. And whatever I do to one side to keep it balanced, I do to the other. So this 12 over 6 gives me 2. So I know that y equals 2. And that is just part of my solution. So I'm going to write this up here. Y equals 2. So we have to find the x value now. Now I'm actually going to, like I said, show you how I can use elimination to find the x value, and that's going to show you another skill that you need to have for using elimination. And what I mean here is I am going to try to eliminate my y's. You might be like, but that's a 2 and that's a 4. How are you going to eliminate them? Well, what matters is that you can find a way using multiplication or division to change one of those numbers so that it matches the other one. And here we should look at this 2 and this 4 and say, hey, if I multiply 2 by 2, that'll give me 4. So, as a reminder, you need to make sure that if you're going to multiply this by 2, you have to multiply the whole side by 2. And whatever you do to one side, you do to the other. So 2 times 3x is 6x, and 2 times 2y is 4y, and here 2 times 10 is 20. I'm going to line this other equation up underneath so we can do our elimination. Okay, so I notice I have a positive 4 and a positive 4, so what I am going to do is subtraction here. So I'll put parentheses around this expression to remind myself I'm subtracting the whole thing here, and I am subtracting this. The reason why this is important is because when I subtract, that's going to affect each term here, because 6 minus negative 3x is the same as saying 6 plus 3x, which gives me 9x. 4 minus positive 4 is going to give me 0, and then equals 20 minus 2 is 18. And let me go ahead and keep that habit of doing that line so we can see where things are. I'm going to rewrite 9x equals 18. I'm going to divide by x's coefficient, so that cancels out, and I know that x is going to equal 2. So if I fill it in up here, this is my solution to the system of equations using elimination.